Hey guys, and welcome to this video on the Python programming language and on machine learning. So in this video, we're going to write some code to explore the NBA players data from the 2013 to 2014 basketball season. And we're going to use a machine learning algorithm called K-means to group the players in clusters. And this will show us which players are most similar. So right now I'm on Google's website called colab.research.google.com. And the reason why I'm on this website is because it makes it really easy to get started programming in Python. So you don't have to install Python onto your computer or laptop. You can simply go to your browser, go to this website, and get a Google account if you don't already have one, and sign in into Code Laboratory. All right, so let's go ahead and get started writing our program by first going up here to the top left, and I'm going to zoom in a little bit, and we're going to click File, and I'm going to come down and click New Python 3 Notebook to start coding our program. All right, and what we see is a cell opens up for us, and we can immediately start programming in Python. So I could print hello, just like that, press this play button here, and we'll see hello being displayed. All right, so I'm going to X out of that. So now the first thing I usually like to do when writing a program is put a description. So here we're going to put a description of what this program does. So this code explores the NBA players from the 2013 to 2014 basketball season. Okay, and it uses a machine learning algorithm called K-means to group them, so these are the players when I say them, in clusters. And doing this will show which players are most similar. Okay, so let's go ahead and create a new cell by clicking this code button, and I'm going to import the dependencies or packages, at least the ones I can immediately think of. So we're going to import pandas as PD, so we're going to give it the alias PD. We're going to import the package cborn as SNS, and we're going to import matplotlib or lib, I believe it's lib.pyplot as PLT. All right, and I'm going to run this to make sure that we don't have any issues. All right, great. So I'm going to create a new cell, and here we're going to load the data. All right, now since I'm using this website here, we have to use a package that Google has for us. So from google.colab, we're going to import files, and they're going to create a variable called uploaded and set it equal to files.upload, and this will allow me to upload the file that we want to use. So I'm going to go ahead and run this, and you can see it gives us this option to choose a file. So I'm going to click that, and I want NBA 2013.csv data. Okay, so now that's uploaded. So I'm going to create another variable called NBA and set it equal to pd.read_csv, and we're going to store this data into our data frame. We have to give it the name of the CSV file that we're using, so NBA_2013.csv, and then I want to print the first 7 rows of data, or the first 7 players. So to do that, just say NBA.head and put 7 there. And now let's run this. Actually, I'm going to comment out this library or this package, and I'm going to comment out the method as well, the upload method. So we no longer need that. So let me run this now. Okay, and so what we can see are the first 7 players in our data set. So we can see LaMarcus Aldridge, Aaron Aflalo. So it's pretty cool. And we can see some of the columns as well. All right, so let's scroll on down here. Let's actually create a new cell and scroll on down. All right, now let's get the number of rows and columns in our data set. And to do that, we just say NBA.shape. All right, and then if I run this, what we'll see is we get 2 numbers. So what those 2 numbers mean is that we have 481 rows or players, and we have 31 columns or features. All right, so that's pretty interesting. We have 481 players for this 2013-2014 NBA data set. All right, so let's create a new cell, and this time I want to find the average of or the average value for each numeric column. So of each numeric column. And to do that is pretty easy. We could just say NBA.mean, because mean of course is another way to say average. And we just run this, and now we get the mean or the average of each of the columns, also known as features. All right, so what this means is we look here at FG, here at FG, we see the field goal average is 192.88 field goals for the NBA season of 2013-2014. So on average, a player is going to get 192 field goals, or 193 field goals, if I round up. All right, so that looks good. Let's create a new cell here. And what I'm going to do, I'm going to comment the code later on to put a glossary of what each of these columns mean. So you'll know FG means field goal, you'll know PTS means points, AST will mean assists, and you got steals and blocks. And I put the link, like I said, for this glossary when I comment this code at the end, and you guys can get this code off of my GitHub. All right, so we're going to go ahead and continue here. Let's suppose that we only want one of these statistics, and we want the mean of only one of them. So here we're going to get the mean or average of a specific column. All right, so to do this, I just say NBA.loc, and I want all of the rows, and I want the column FG. All right, and I want the mean of that column. So now if I just run this, I get back just the mean for the field goal, so for FG. And if we look up here to FG, we'll see we do get 192.88149, and it looks like it actually rounds off here, but down here it continues. After the 9, we get 688.149.687. So it looked like it gives us a little bit more after the decimal place, a few more numbers after the decimal. All right, so let's continue exploring the data. I'm going to create a new cell here, and let's make a pairwise scatter plot. So we're going to make a pairwise scatter plot. Okay, so this is a common way to oops, I added a new cell on accident. This is a common way to explore a data set to see how different columns correlate to others. And what we're going to do is compare the assists column, the field goals column, and the total rebound column. All right. So to do that, all we do is say sns.pair plot, and we put in NBA. Now, of course, we could run this right here by itself, and it will do this scatter plot, this pairwise scatter plot for all of the columns, but that could take a very long time to load. So that's why I'm only choosing 3. And so to choose specific columns, we just put the brackets here, and then another bracket, and then put assist, field goals, and total rebounds, TRB. All right, so let's run this. Okay, and we see we get back a pairwise scatter plot. So you can see a correlation between these columns. Okay, so now let's go ahead and go to a new cell here. And what am I going to put here? Let's do a heat map. So here we're going to make a heat map to see correlations. Now I could make a heat map of all the columns, but again, that would take a very, very long time. So we're going to make a heat map of only a few of the columns. So to do that, first let's take a look at the correlations. So I'm going to say NBA, and I'm going to put this in brackets, and we're going to basically look at the same columns that we looked at up here. So I'm just going to copy it by highlighting this and doing Control C, and coming down here and pasting it here with Control V. And then I say, then I will put .corr, and this right here will give us the correlations. So we can see the number, we can see the correlations, but we want to make a heat map using these correlations. So let me set this equal to a variable that I'm going to call correlations, or correlation. And then we're going to use SNS again. We're going to use that Seaborn package and the heat map method to do this. So we're going to input correlation, and let's run this. And now we get a heat map of our data. Now, this may not be as informative as those numbers, so I kind of want to put those numbers back. And to do that, I just put comma here and put annote equals true. And now if I run this, we can see those numbers and the heat map together. So I think this is a better visualization to look at for these columns. And of course, I could just put in all of the NBA data frame. So I could put NBA here, and we can see all of the columns and how they correlate. But again, that would take some time for it to load. All right. But actually, I probably should also mention on here is we can change the runtime. Since we're on Google Colab, we could change the runtime type to be GPS CPU. So I probably should have did that in the first place, and it would have sped up the time to actually run this. But for now, this is what we're going to work with, and we're just kind of exploring the data and getting a feel of what the data looks like and how to explore the data. So I'm going to go ahead and create a new cell. All right. And here we're going to make the clusters of the players using the machine learning model called KMeans. So I just put in comments here, make the cluster of players using KMeans. All right, so to do this, I do need another package that I did not put up here at the very top. So I didn't put the package up here. So we're going to put it down here since we need to use it now. And to use it, I just say from sklearn.cluster, we're going to import KMeans. All right. And so I'm going to create a variable called KMeans Model and set it equal to our KMeans method. And we need to tell it the number of clusters that we want. So in cluster, or clusters with the S, is going to equal 5. We're going to have 5 clusters. I'm just choosing an arbitrary number, 5. And then random state, you don't have to worry about too much. but I'm going to set it equal to 1. You can set it equal to any number you want to, like 41. So I just set it equal to 1. So we're just going to create 5 clusters using this model here. And let's see, we want to make sure our data is clean. So I want to remove any non-numeric columns or columns with missing values. So that's columns with NA or NaN, etc. So I'm going to create a variable called good columns. Set it equal to NBA dot get underscore numeric underscore data. So that's another thing. I'm only going to get numeric data, and I'm going to get data that's not missing. So we're going to get numeric data and columns without missing values. All right, so let me make sure I'm doing this correctly. I think it is, that's a method. We're going to say dot drop in A. So now we're dropping any missing values, and we want to drop this on the column. So we say access equals 1. So let me make sure you guys understand this. We're taking that that data frame that we have, NBA. We're getting the numeric data, and then we're dropping all of the missing values on the column. So that's where we have the access equals 1. All right. So hopefully I wrote all that out correctly. All right, now let's train our model. So to do that, we just say KMeans underscore model dot fit, and we're going to fit our good columns. All right, so I should probably comment this. Let me say train the model here, get numeric data and remove missing data from the columns. Get numeric data and remove columns with missing data. There we go. And here we are creating KMeans model with 5 clusters. All right. Okay, and let's see, we want to get the labels for each cluster. So that's it's going to be 5 labels since we're going to have 5 clusters. So I'm going to create a variable called labels and set it equal to KMeans underscore model dot labels, and then that underscore at the end. So this right here should get the labels or cluster label for each player. All right, and then I want to print those labels, so I'm just going to put labels here. All right, let me run this. Hopefully everything is good. Excellent. So you can see we get numbers 0 to 4, and so that's 5 different clusters. So it's labeling each of the rows of data as either 0, 1, 2, 3, or 4. And of course, each row of data is a NBA player. So that looks good. All right, so let's go ahead and create a new cell. All right, and let's actually start plotting the players by cluster. So in order to do this, well, first I should probably put a comment here of what we're going to do. So we're going to plot players by cluster. So I'm going to use something called PCA. That's a method from sklearn. And PCA stands for Principal Component Analysis. It's basically like a dimensionality reducing algorithm. And we want a two-dimensional clusters here. So anyways, let's go ahead and get started. So I need to use another package. I need to use sklearn again, but this time sklearn.decomposition. Okay, and from that we're going to import the PCA method. So let me scroll up. All right, there we go. And I'm gonna create a variable called PCA underscore 2 and set it equal to our method PCA. And we only want 2 dimensions, so I'm going to put the 2 there. So this way we can plot out the players by cluster to discover patterns. All right, and let's see, what else do we need for PCA? I need to make a transformation of it. So I'm going to create a variable called plot underscore columns and set it equal to PCA underscore 2 dot fit underscore transform, and we're going to transform our good column so we can get the x and y coordinates. All right. So if I show you guys what that looks like, if I do plot underscore columns, you'll see coordinates now. So you can see these coordinates and the x and y coordinates. All right. So that's basically what we're doing here. That's what we're creating. And we're going to plot that. We're going to plot it. We're going to do a scatter plot. So now I just say plt dot scatter. So remember, we use this alias further up from our package, and we tell it the x coordinates. So that's going to be plot underscore columns. We want all the rows from there, from 0, and then the y will be plot underscore columns, all the rows from that column, and we will, the C will be the labels. So we created the labels up here. That's going to be 0, 1, 2, 3, and 4. So that's what we're putting there. All right, so now let's show the plot. So do plt.show. And if I run this, hopefully I didn't mess up. Ah, nice. So very, very nice. So now we can see our scatter plot. And we can see the labels 0, 1, 2, 3, 4. All right, they're just different colors. All right, so let's go ahead and create a new cell. Okay, I want to show, let's find LeBron James in the data, and then let's see what cluster LeBron James belongs to, and then maybe do the same thing for another player that we think is similar. So I'm going to create a variable called LeBron, or maybe I should call it player, but I'll call it LeBron. And LeBron is going to equal the good columns dot LOC. So we're just going to get LeBron from good columns. So that's where NBA player is equal to the name LeBron James. All right, and I want all of the columns. All right, so let's run this. Hopefully that's okay. Yes, all right. And let's print out LeBron. Okay, there is no LeBron, so that's probably because I'm misspelling. So if I do a capital B here, and actually I'm going to change this variable to a capital B as well. Let's see what we get back. Excellent. So yes, spelling does count, capitalization counts when trying to find a player. All right, so now we have our player LeBron. Let's create another player. Let's do maybe Kevin Durant. He'll be a good one. So I just put Durant and set Durant equal to basically the same thing. So I'm going to copy this up here, highlight it, do Control C to copy it, come down here, Control V to paste it, and this time we're going to get Kevin Durant. So that's capital K-E-V-I-N and capital D-U-R-A-N-T. All right, and oops, I create another cell. So I want to print this time LeBron, and I want to print Durant. Okay, so let me run this. Excellent. So now we get data for LeBron James up here, and we get data for Kevin Durant down here. All right. So we have our players, two of our players, and now let's make a prediction using that K-means model. So first thing I need to do is create another variable. I'm going to call it LeBron list because the model only takes in a list, and it's going to be LeBron dot values dot to list. All right, hopefully that does it. Let's run this. Okay, and I need to create a Durant list, and so I could basically do the same thing. Durant dot values dot to list, and run that. Okay, so now I've converted our data into lists, and now we're going to use that K-means model that we created earlier to predict what cluster they belong to. So let's predict LeBron underscore list. Let's see what cluster he belongs to. So here it tells us he belongs to cluster 3. So here I'm going to put LeBron belongs to cluster 3. And let's I can put Durant in there. So we're just going to copy this, Control C and Control V to paste it and run that. And Kevin Durant belongs to cluster 3. All right, I should probably make these variables. So I will say LeBron underscore cluster equals that. Oops. So I still have Kevin Durant there. Let's just copy and paste this. And we're going to make this LeBron. And then I'm going to create the Durant cluster below here. Okay. And there we go. So let me make sure I comment the code. So here, converting the data into lists for model prediction, and then the cluster classification of LeBron James and Kevin Durant. And then we're going to print the cluster label. All right, so here I'm just going to say print, and then we're going to do another print statement, print, and we're going to print LeBron cluster and the Durant cluster. Okay, so they both belong to the same cluster, cluster 3. All right, and did I comment my code up here? I did not. So here I will comment my code. So here I'm going to put find player LeBron. And here we're going to find player Durant. All right, and then we are printing the players, print the players. All right, so I think that looks good. So just like I thought, Kevin Durant and LeBron James belong in the same cluster when we are clustering, when we have 5 different clusters. So that's pretty cool. All right, let's see, what else do we want to do to kind of explore this data? Maybe we want to look at all of the column correlations. So to do that, I just say NBA dot core. So this is all of the columns. I'm not sure if I showed you guys this earlier or not, but you can see they have negative correlations and positive correlations, and that's pretty cool to just kind of see all this data. All right, so let's go ahead and create a new cell, and let's say we want to predict the number of assists per player from field goals made per player. All right, so how do we do that? How do we make this prediction? Well, one way we could do it is to use a machine learning model called linear regression. So let's do that. But first we need to split our data. So again, I'm going to use another package from sklearn.model selection. I'm going to import a method called train underscore test underscore split. And I'm going to create the variable xtrain, xtest, ytrain, and ytest. Okay, so now I'm going to set it equal to that method. So I'm just going to copy this up here, doing Control C, come down here and do Control V. All right, and we need to tell it what data we want to train on. So we want, to split on, not train on. So we want to split the data from NBA FG, that's the field goals, and the target will be NBA assists. So we have the features that we want to split the data on. We call it the X, or the independent variables, and then we have our dependent variable, which is the assists or the target. Okay, and we need to tell it how to split this data. So I want to split it 80% training and 20% testing. So to do that, I just say test underscore size and set it equal to 0.2. So now we have 20% testing and 80% training. Okay, and then we have to give it a random state. And I'm just going to choose some random number or some arbitrary number like 2. And you can choose any number as well. Just make sure you keep the number the same when, I guess, when splitting your data. Well, it really depends on what you want to do. So the number really is arbitrary in this case. You don't have to worry about it too much. Okay, so let me go ahead and run this. Hopefully there's no errors. And we do get back some errors. So let's see where the errors are. So I have NBA 1, 2, 3, 4 variables. We have our train test split method from the sklearn.model selection, and we are splitting on NBA FG, NBA, ASST. There's no column called ASST. Let's run this again, and now we have this cell working fine. So now we have split our data. So let me go and comment this. So we're splitting the data into 80% training and 20% testing. Okay, so I'm going to create a new cell, and this time we're going to create our linear regression model. So let me go ahead and put that here. Create the linear regression model. Okay, so I'm going to create a variable called LR and set it equal to linear regression method. All right. And now I want to train our linear regression model. So to do that, we just say lr.fit. So fit's another word for train. And we're going to input our data to train on. So that's our X train and our Y train data. And again, this is training the model. And then we want to make a prediction. So I'm going to create a variable called predictions and set it equal to lr.predict. And it's going to predict on the testing data. So it's going to make predictions on that testing data. And I put that here, make predictions on the test data. All right. Now let's print those predictions and let's print the actual values. So that's Y test. And I put that in comments here. Print the predictions, and here print the actual values. Okay, so let's run this. And it looks like I have an issue here. Let's see, name linear regression is not defined. And that's because I never imported my package. So let's go here. So from sklearn.linear underscore model, we want to import linear regression. Okay, so that was my fault. Let's run the cell again. And now we see our predictions. So it predicted a value of 36. And remember, we're predicting the assists per player from field goals made per player. So maybe I should put that somewhere here as well. So we'll put that up here. Predict the number of assists per player from the field goals made. All right. So this is the number of assists. So it's predicting that there's 36 assists on that on this testing data for that column there. And let's see, the actual value, if we scroll down, is 72. So not very close, not very good. The next value is predicting to be 29 assists. And let's scroll down and we get 44. So this model doesn't look very good, but let's go ahead and create a new cell and check the check how well our model is doing. So let's test our model. So here I put test model. And to test the model, we can get the score, and the score returns the coefficient of determination. R squared of the prediction. Okay, so the best possible score that this can be is 1.0 when we're done with it. So I'm going to create a variable called LR underscore confidence and set it equal to LR dot score. And so remember, LR is our model and score is going to be the method that we're using to score the data. And we're going to score on the test data and the X and Y test data. So we're just scoring on the test data. All right, and then I will print LR confidence, put a space there, and then we'll put LR underscore confidence. Okay, so let's see that score. All right, so we got a score of 0.435, which is not really that good. What this means is, this means that 43.53% of the variance for assists is explained by the field goals the player made. So that's not good. Our model is not good, but this is a good way to test this. So that's basically it for exploring this data a little bit. I thought it was pretty fun. Please leave any questions you have in the comment section. Don't forget to hit that like button and that subscribe button. I'll be sure to put a link to this code in my GitHub and put it in the description below. And as always, guys, thank you for watching, and I'll see you all in the next video.